So this problem deals with a space heater, and we are going to run it at 120 volts, and it has a resistance of 14 ohms. And the key word there, it says a hot resistance. As the temperature increases, the resistance of an object goes up, and that's because the average kinetic energy of the molecules will increase. They'll start to vibrate more rapidly as the temperature goes up, which makes it more difficult for the electrons to move through the material. So this just says after it heats up, this is the resistance. Now what we want to find is the electrical energy. Now electrical energy is power times time. So E equals PT is the equation. Now in this case, we know voltage and we know resistance. And there are three versions of the power equation. So it's either VI times time, so P equals VI, I squared R times time, or V squared over R times time. So all three of those are equivalent in terms of energy. We're going to use the V squared over R. Now the other thing is, it's saying the rate at which the electrical energy is transferred. So that's assuming that you have a time of 1 second, and that's hidden within the question. And this textbook it commonly does problems in that fashion. So it's going to be E equals V squared over R times T, 120 volts squared over 14 ohms times 1 second. And that'll give us the electrical energy. It also will give us the electrical power, since power is V squared over R and we're multiplying it by T anyway. So what I'm going to do is I'm going to calculate 120 squared divided by 14. I'm going to say times 1, but I get 1028.6. And since we're finding energy, it's joules. So every second, the energy is 1028.6 joules, and that really means the power is 1028.6 watts. So that's what we start with, and that is the beginning of the problem. So we're dealing with part A. So part A is 1028.6, and that's the energy in joules, and then 128.6 watts would be the power. Now we have the second part. So B talks about money, and you have 0.522 cents per kilowatt hour. Now a kilowatt hour is the amount of energy that is provided by 1,000 watts in an hour. So it's the energy equivalent of 1 kilowatt for an hour. Since time always has to be measured in seconds, that's really 3,600 seconds, because 1 hour is 60 minutes times 60 seconds. So it's 3,600 seconds. A kilowatt is 1,000 watts. If you multiply these two, you get 1,000 times 3,600, which is 3,600, 000. And this is the number of joules in a kilowatt hour. So 1 kilowatt hour is 3.6 million joules of energy. And this is a conversion that we need to know in order to figure out the amount of money that it costs to run some kind of component, in this case a space heater. Now if we're running this for 6 hours and 25 minutes, that means every second we're using up 1,028.6 joules of energy. So we need to convert this to seconds. So 25 minutes to seconds, and then 6 hours to seconds. And I'll do them separately. 6 times 3,600 is 21,600. So this alone is 21,600 seconds, plus 25 times 60, because we already in minutes there, is 1,500 seconds. 21,600 plus 1,500 is 23,100 seconds. So the total time that the space heater is operating in this case is 23,100 seconds. So If we want to find the total energy, we're going to do PT. So 1028.6 joules times, and since the time's already there, I'll leave it. So times 1028.6, and we get a huge number, 2376. It's not 2376, it's 2376, 0660 joules of energy. And here this should have been watts, because watts are joules per second, and joules per second times seconds gets you joules at the end. But this number here is a piece of the kilowatt hour. So here's what we do. We convert this number to kilowatt hours. So it's 1 kilowatt hour. 1 kilowatt hour. That's on the top. And it's 3.6. I'm just going to write megajoules because I don't have a lot of room on the board here. But mega, as we know, is 10 to the 6. So it's really 3.6 times 10 to the 6 joules. So we take this number, divide it by 3.6, E6. We get the number of kilowatt hours, which the total energy is this number, and the kilowatt hours is 6.6 kilowatt hours. And if every kilowatt hour costs 5 cents, you do 0.0522 times 6.6, and you get a total 0.0522. You get a total cost to run this space heater for 6 hours and 25 minutes of 34.45 is this part, but really 34 cents. So the total cost is 34 cents to run it. So the answer to the question, what is the cost for part B? What does it cost to run the device? 34 cents. And the part A, so this is A here, and this is part B. All right, that's how you do the space heater problem.